Welcome to ADCO Aviation. On the 30th video, we discussed how I designed my iron crosses for my Legal Eagle XL. Today's video is a little longer and a little different than most of my build videos. I've always said I didn't want to make a how-to video, but on today's subject, it's probably more of a how-to than most. I thought I'd discuss antennas and how I built mine. I know we don't have to have radios if we're not flying in certain areas, but I think it's good practice to have one. I plan to use my Vertex Pilot VXA 210. Of course, I could just use the rubber ducky that came with it, or maybe even better, a quarter wave whip antenna. I decided way back that I was going to add an inverted V half wave dipole antenna to make sure I can hear as much as possible from the local traffic, and hopefully they can hear me better too. Some of you may remember I welded on 2 tabs on my fuselage for this antenna, so hopefully we will not add very much weight for this antenna. I have read and saved an article, A High Performance Airband Antenna for Your Ultralight, written by Dean A. Scott from 2007. I'd recommend you Google this article and read it. There's a lot of information that I won't be covering here. So this is a simple, easy to construct, and easy to mount inverted V half wave dipole antenna that should significantly increase our range and clarity of communication if we trust and follow these steps. It's designed for Unicom and air-to-air communication frequencies between 122 and 123 megahertz. It's made of 2 stiff wires about 12 gauge. I'm using welding rods cut to 23 and 5/8 inches long, forming a 120 degree angle. First, I use the welder to weld a ball on the end of each of the wires. This is more of an anti-eye poker outer than something the antenna design requires. Better to be poked with a blunt, rounded point than a sharp-edged skewer. Next, I measured from one end of the ball and placed a mark at 23 and 5/8 inches. I put 2 3/16 inch rods in the vise and started just before the mark, trying to get the center of the loop at 22 and 5/8 of an inch. I bent the end around and clipped off the extra wire, cleaning up the curve with a pair of pliers. These are our antenna elements, or whiskers. I should have taped off the newly formed loops, but forgot. I painted the whiskers to protect them from corrosion, so I had to sand the paint so I'll get good contact with the washers and cable. We'll come back to these in a bit. Next, we needed to devise a way to mount these 2 antenna whiskers so that they're held firmly in place at the desired 120 degree angle, while at the same time providing electrical isolation from the elements from other metallic parts of the system and airframe, and allowing us to connect the terminals to our RG58 coax antenna cable. I had some scrap UMHW that was about 2 inches wide and 5.5 inches long that was about a half an inch thick. 3/8 of an inch thick would be fine. I suppose a good source of this would be a heavy-duty cutting board. Anyways, I drew 2 lines, one dividing the length of the block in half, and another perpendicular to this that was a half inch below the top edge. On this line, I marked the locations of the 2 antenna terminals, one on either side of the center line and about 3/4 inch apart. I took a 120 degree template and lined it up with each hole and the corners, and drew out the 120 degree lines where the whiskers will go. I hope this makes sense. Next, I came up a half inch from the bottom of the block to mark the location for mounting the B and C connector. I also marked the mounting holes based on the desired position of the block on the fuselage. I drilled these 5 locations with an 1/8 inch pilot bit. I countersunk the antenna terminals with a 1/2 inch wood bit about 1/4 inch deep enough to add aluminum washer and then the whisker to lay flat once the grooves are cut. I countersunk the BNC connector hole with 11/16 inch wood bit as deep as needed. You'll only want about an 1/8 inch of plastic left. The BNC connectors don't have much threads, so take it slow and be careful here. After I countersunk all the holes, I drilled the center of the mounting and antenna terminal holes to size with a 3/16 inch bit, and the BNC connector with a 3/8 inch bit. I then set my skill saw to 1/8 inch deep and made a single pass where the whiskers was going to lie. Then with my Dremel with a small cutoff wheel, I slowly cleaned up and widened the groove to accept the whisker to approximately an 1/8 inch deep and wide. I then pressed the aluminum washers into the recesses and mixed up a small batch of T88 to bed the whiskers into the grooves. I clamped them down overnight. The next day, I placed the BNC panel mount connector into the 3/8 inch hole from the back side so that the center terminal of the connector sticks up into the countersunk side of the block. I tightly secured with the supplied solder tab washer and nut. I will drop a drop of super glue to make sure it doesn't vibrate loose. I then stripped the center wire of a coax cable and made loops in the ends of each wire to fit the number 10 machine screw and bent them as needed to reach the terminal of the BNC connector. I placed some dielectric grease at the end of each loop and between the pairs of washers of the antenna terminal screws and soldered the other end to the BNC connector. The center connector goes to one antenna element and the ground goes to the other. The article didn't say, but I noted the whisker that went to the center post was pointing down. I don't think it matters, but I did the same just in case. Anyways, I attached the antenna element to the block with the number 10 machine screw. I added a second flat washer onto the back for the screw of the middle wire. We'll use this in a bit. Almost done. We also need to add a Pawsey stub balun. Why? I have no idea. Something about balancing the electrical condition caused by coax cable. It has something to do with the way RF current flows only on the surface of a conductor and not in it, and how current flowing on the outside of the center conductor induces an equal and opposite current on the inside of the cable's braided shield. These guys have this down to a science. My dad is a ham operator, and I've helped him build several antennas. I just follow their instructions. That way I don't have to take Tylenol. And I trust that it will work. I need to note here, I'm using RG58 coax cable. And for RG58, you need to cut a 15 1/4 inch length of RG58 coax cable for the balun. I first stripped about 1.5 to 2 inches of rubber jacket off the end. I twisted together the exposed strands of the braided shield and tinned them with solder to create a pigtail. I then cut the center conductor and plastic shield about an 1/8 inch past the pigtail. Measuring about 16 inches from this cut center conductor, I cut off the cable. Now, measuring 15 1/8 inch from that end, I stripped the other rubber jacket and repeated the twisting and tinning of the braided shield. And finally, measuring 15 1/4 inches from the first end, I cut the center conductor and the plastic shield, which again was about an 1/8 inch past the new pigtail. I clipped this soldered pigtail to about 3/32 inch long, and will solder it to the cable soon. I mounted the antenna block to my airframe so that the whiskers were vertical and facing forward, also making sure they won't come in contact with any part of the frame. On the first end of my coax cable, I made a loop from the pigtail and put it under the antenna's terminals nut and washer with more grease that is connected to the center conductor of the BNC jack. The article says to connect it as close as possible. Next, I zip tied the Pawsey stub to the radio's coax cable as close as possible to the BNC connector. I then taped the Pawsey stub alongside the cable, making sure there were no gaps between the stub and the coax along its length. At the point where the Pawsey stub short pigtail touched the coax cable's jacket, I cut approximately a 1/4 inch square window in the outer jacket only to expose its shield braid below. We have to be careful here and not cut through this shield. I applied a small bead of solder to the shield exposed in the window. Then, using heat sparingly to avoid melting the center conductor's insulation underneath, I reheated and reflowed the solder to attach and join the stub's pigtail to the shield of the radio's coax cable. I finished the spiral wrap of the whole length of the stub and coax with a single layer of electrical tape, and then added some spiral cable wrap to tidy things up. They say when this antenna is oriented vertically, as shown, you'll get the best near omnidirectional coverage possible as shown in this radiation pattern. Theoretically, aircraft directly above and the ground stations directly below you will not receive a very strong signal when you transmit, and conversely, you will not receive a very strong signal from them either. Your best reception and transmission is going to be towards the horizon, where 99% of all the planes and ground stations live anyways. The only thing left to do now is to go out and fly and see if this antenna improves my reception, and if others can more clearly hear me and further away. I can't wait to give this a try. Anyways, I hope you've enjoyed this video and hopefully found some of the info helpful for your build. And if you're on the fence about starting a Legal Eagle build, hopefully I've shown you just how easy it can be. And if you like these videos, please like and subscribe to my YouTube, Odyssey, and Rumble channels. Thank you, and be safe.